Hi, this lesson is all about the effects of earthquakes. Earthquakes have one main primary effect. They shake the ground. But the number of knock-on or secondary effects they have is really quite diverse. They can do all sorts of strange things, like we can see in this image from just taken just outside Christchurch after the 2011 earthquake. And you can see how compression of the ground here has had quite a dramatic effect on these railway lines, which clearly aren't going to be in use until this all gets fixed and sorted. Okay, we're going to have a look through some of the different effects of an earthquake. I'm going to do this fairly quickly. You'll see in the lesson notes that there's a whole series of links to videos you can watch to see these effects actually happening in real time. The first effect is perhaps the most obvious: structural failure. If you shake the ground, buildings built on that ground can collapse. Now, the image you can see here was taken in Turkey in 1999. You can see the effect of a fairly major earthquake on what we call an unreinforced masonry structure. If you look around these collapsed buildings, which have fallen, so they've sort of pancaked down on themselves, the roof has fallen on the floor below, which has collapsed onto the floor below that, and so on. You can see around the buildings the rubble from the walls that support the roof and the upper floors that has fallen out, leaving the floors and roof unsupported. This is pretty catastrophic for people living in these buildings. One point that's worth noting, though, if you look at the apartment block just next to these two that have collapsed, you'll see it's largely undamaged. Clearly, the quality of building does have an impact on how it reacts in an earthquake. More modern buildings, such as this one from Kobe in Japan in 1995, that have a steel frame, are more likely to create survivor space. I mean, here you can see the building is fairly catastrophically damaged, but really, for anyone that's in that building, although it'd probably be quite terrifying, their chances of survival are quite high. You can see that each of the floors has void space within it. There's definitely survivor space in there, even though the side of the building has fallen off. Clearly, though, you won't want to be on the outside of that. Now, some of the structures that are most vulnerable are bridges. This is a picture taken after the 1989 San Francisco earthquake. This was an urban motorway. There were three decks to this. There's the street level, a deck above that, and a deck above that, with carriageway going one way on one deck, carriageway going the other way on another deck. You can see how the floor of these bridges, just like the flyover in Cowbridge, I suppose, has actually collapsed and broken when the earthquake occurred. The earthquake in San Francisco, as we know, happened at evening rush hour. This did kill people. People were trapped in cars underneath this. Another effect of an earthquake are landslides. Where we have slopes that are perhaps unconsolidated and perhaps are prone to instability, shaking the ground can be the trigger that reduces friction enough for the landslide to occur. One of the biggest effects, and one that several links in the lesson notes refer to, is this idea of liquefaction. Liquefaction is where we shake wet, unconsolidated sediments. Think of wet sand, for example. What happens then is water gets in between the grains of sand, and the material then will start to behave like a liquid. It behaves like quicksand. You can see in this building, this was in Kobe in Japan, okay, or this unfortunate person's car in New Zealand, in Christchurch in 2011, things will sink into the ground. Where there's a weight on the ground, if it's behaving like a liquid, the liquid will flow away from where the weight is, and whatever's sitting on top will sink. Whether that's the building, we can see that the building is actually undamaged. It's just sunk. Or a car, it will be consumed by this very liquid mud. There's some videos in the links to show you how this works. One of the other effects that can happen is fire. This image was taken in San Francisco in 1989, but it's not an uncommon thing. Kobe in 1995 had similar issues. One of the things that can break are things like gas mains, electricity cables, oil tanks. The combination of these can lead to fires breaking out. San Francisco in 1906 was devastated almost as much by the fire as that were caused by the earthquake as the earthquake itself. There is something about this photo, though, that gives me hope. The triumph of the human spirit. And it's this person wearing number 14 there. I'm always impressed when I look at this. You know, these houses in front of him are a raging inferno, but number 14 is going to sort it out. He's got his bucket, he's got some water, he's going to deal with the problem. So, there are a whole series of different effects of earthquakes. We can have movement of the ground, perhaps even breaking it, as we saw in Christchurch, causing transport difficulties. Structures can and will fail. We can have this big problem of liquefaction or fire. Perhaps the biggest secondary effect we can see are tsunamis. More about those a bit later in this theme. Now, when we think about the causes, what can actually make this worse? Obviously, the geology has something to do with it. The bedrock geology can have a big influence on the nature of the earthquake hazard. Generally, solid bedrock is better to be in an earthquake than loose unconsolidated sediment. Loose sediment can not only liquefy, but it can also magnify the amount of shaking and prolong the duration of shaking. Think of jelly in a bowl. If you shake the bowl, we get movement, we get an earthquake. If you stop shaking the bowl, the jelly will keep moving. Unconsolidated sediment can behave like that. But it's not just the geological factors that have an influence on the nature of the hazard. There are some geographical factors as well. Higher population densities will increase the effects. A big earthquake in Alaska has very little impact. A smaller earthquake, perhaps somewhere like India, can have a much bigger impact. The wealth of the country. If a country is more economically developed, chances are the buildings are better, infrastructure is better, emergency procedures are better. You know, the capacity to cope with a hazard will be greater than it would be in a less economically developed country that doesn't have access to these things. Educating the public is really important. Knowing what to do. I know, for example, in New Zealand or Japan, it's part of the school curriculum to train people how to deal with earthquakes, how to prepare for them. In the same way that in Cowbridge we would have fire drills. In New Zealand they'll have earthquake drills. And finally, communication of this to the public. How you actually get the message across that an event which is perhaps unlikely is worth preparing for. Okay, so we can see that there's a whole range of different effects of these earthquakes. Have a look at some of the links that I've given you in the lesson notes. Click through those, watch these things happening. Think about how they would have knock-on effects then, making the hazards created by the ground shaking even worse.